In this video, we will be reviewing the terms parameter and argument and practicing looking at example Java code and identifying these two items in example code. This will be our first step towards understanding how the Java compiler determines which arguments to connect to which parameter values. So I want to begin by reviewing the terms parameter and argument. A parameter is part of a method that we're writing. A parameter can be part of a method that we write on our own or part of code that's written and part of the standard library. As we're writing a method body on our own, we don't usually know what actual values the algorithm is going to be carried out with. Think about the people who wrote the standard library. When the standard library authors were writing the string class, they didn't know what value you were going to use to call the character at method at a particular point in your program. They didn't know whether you'd be passing in index 0 or index 5 or index 500. And so they didn't have any information about the actual value that the algorithm would be carried out with. Instead, as they created their code, they used a placeholder name in their method body to represent the idea, the logic of the value that would be used in that particular algorithm. That makes the algorithm really flexible so that we can use it over and over again with lots of different values. If we had created a method and just hard-coded in a specific value, it would only be useful maybe in a small subset of situations. Like, for example, that character at method in the string library. If it were set up so that it only worked with index 0, we'd only ever be able to look at the first character inside the string. But because we're allowed to pass in any value and the algorithm's written with the placeholder, it makes it really flexible. This idea might seem a little bit weird, but really this type of abstraction is familiar to you. For example, sometime in your math career in middle school or high school, you probably talked about geometry and wrote formulas for things like how to calculate the area of a rectangle, where you might say something like the area is equal to the width times the height. And when you say that, it doesn't mean take those characters and those individual words and multiply them together or something. It means think about what in your problem description is the value that's associated with the width and what value in your problem description is associated with the height. And then take those two values in your specific scenario, the two actual values, and plug them into these ideas, the width and the height. And so width and height are really just placeholder values that tell you how to combine together your actual information to make a calculation to get the result of the area. And so when we're writing methods, it's really the same idea. One of my tips is to remember that parameter and placeholder both start with the letter P, and that's how you can remember that they're connected. Let's look at some example code. I have the binary search algorithm written over here. So let's take a look at that and let's try to identify the parameter values in this program. Remember, the parameter values are part of the method, and so it's not the information in the main program, it's the information in the method that we've written. So in our example program, that's the binary search method, and the parameters are always the information that's up here at the top inside the parentheses. So in my program, the binary search method takes two parameters. They're called list and key. And those are the placeholder values that I used in my binary search algorithm to indicate the array of information that we're looking through and also the key value that we're looking for. So as I coded up the binary search algorithm, I was careful to use those identifiers, list, that's my collection of information, and also key, that's the information that I'm looking for. I used both of those placeholder names inside my algorithm because I didn't know what actual values were going to be used by somebody calling my method. So again, list and key, those are the parameter values for this example program. Whenever you're the programmer writing a particular method, you need to think about what information does this particular method algorithm need to know in order to make everything work. So again, for the binary search example, we know that to perform binary search, we need to know what is the array of values and also what's the key value that I'm looking for. If I know those two pieces of data, then I can carry out the binary search algorithm. Whatever those key pieces of information are that you need to know, those are the things that are going to become parameters in your implementation. So in your notes, it asks you for the placeholder names for the binary search method. Remember, those are just list and key. Let's move on now and talk about arguments. Arguments are the actual pieces of information that are provided when a method is actively called. These are the data values that get transferred from the calling block in our program, which is usually main in our examples. And those data values get pulled into the method that's being called. So binary search in the example program that we're looking for. So we're looking for these arguments as a way of communicating information from the main method into the method that we're writing, the binary search. Remember that the arguments represent the actual values, and those both start with A, so that's how you can remember that the arguments are the actual information, not the placeholder. So you might be wondering, how does the computer figure out which argument goes with which parameter value? And you might imagine that it does something really complicated and sophisticated to match up like the arguments that best match with the individual parameter values. But there's much less sophistication into the decision than you probably expect. You might think that the computer can tell based on the data type of the parameters. The computer is just looking at the information as a sequence of zeros and ones. It can't really figure out which individual integer value has which kind of abstract meaning. So for example, like if we're thinking about that area calculation that we talked about from geometry class, where the area is equal to the width times the height. If you just have two numbers sitting in front of you, like 5 and 7, there's no reason to suspect that the 5 is the width and the 7 is the height, or vice versa, that the 7 is the width and the 5 is the height. The computer can't really tell the difference. So if we had like a method called update value and we knew that it took two parameters, X and Y, and we wanted to use the method to set up a particular value at a particular position in the array and set it equal to a new value. So one of these is representing an index and one of them is representing the value. If we just look at these method calls, we can't tell which one correctly sets the array at a particular position to a new value. Like if we wanted it to set the value at index 5 equal to the value 3, we can't tell which of these method calls does that. It could be just as likely that it's the top one as it is the bottom one. The only way we'd be able to tell is if we had like documentation that gave us more details about that. And that's just a lesson to show you that the computer can't tell this either. There's no way for the computer to guess that the first thing means the index and the second thing means the value, or that the first thing means the value and the second thing means the index. So the computer doesn't try to match things up based on value or any type of context about the name of the argument versus the name of the parameter. It doesn't consider that at all. Instead, the computer uses a really simple scheme to determine which arguments are paired with which parameters. And it's just based on order. So the very first argument that's listed gets paired up with the very first parameter. Second argument gets paired with the second parameter. Third argument gets paired with the third parameter, and so on, for as many parameters as there are in your program. So for example, if we knew that that update value method had this particular method signature, if it was clear that the first number is representing the index and the second number is representing the value, then we would be able to correctly figure out how to call that method, how to pass in the actual values. So if we wanted to set the list at position 5 equal to the value 3, we'd have to call it with the 5 first and the 3 second. That would pair up the 5 with the index, because those are both the first things. And the second value, the 3, would get paired up with value, the second item, because they're both second. If somebody called that particular method with the reversed arguments, if you called it with the 3 first and the 5 second, what do you think would happen? Do you think it would still correctly set the value at position 5 to be the value 3? No, it wouldn't do that, because the computer always just pairs up the first argument with the first parameter. So it would think that 3 was the index, and then it pairs the second argument with the second parameter. So it would pair the 5 with value. What if we tried to call it with 3 arguments? What do you think might happen? If you guessed that that wouldn't compile, that is correct. And that's because the computer would say, hey, I can't pair all of these things up. I'm trying to pair up the 5 with the index and the 3 with the value. I'm good to that point. But now there's nothing that pairs up with this number 1. So I'm looking for a method implementation that takes 3 parameters to match up with my 3 arguments, but there isn't one in my program. So it would give a compilation error saying that the method for update value looking for an integer was undefined. How about this last example? Suppose we tried to call update value with 2 decimal values. What do you think would happen? So you might think that it uses some sort of type coercion to match these up and to create the 3 as the index and the 5 as the value. But remember that Java can't do that. If you have a floating point value, it can't lose precision to force the 3 to be an integer or the 5 to be an integer, even though we can see that they're both actually whole numbers. So in this example, it would also give a syntax error. It would say it's looking for an update value method that takes 2 floating point values or 2 doubles, and it can't find the implementation for that because the parameters are a integer data type in the definition of the method. So at this point, we've reviewed the idea of arguments and values. We practiced looking at the parameters in our program. Let's look at the arguments as well. So if we look at our arguments, those are the parts that are in the method call. This line right here, line 22 in our main program, that's where the binary search method's called. In this particular example, my arguments are called array and search value. Those are both variables that are defined in the main program. And you'll notice the scope of those values is only in main. If we try to access either of those values directly down here in the binary search algorithm, it will give me red squiggly stuff. If I try to say like search value equals 0, you can see the search value turned red, and it tells me that I can't resolve that symbol. That's because the search value is not defined. It doesn't have scope down here. So the arguments are only included up here in the main. And vice versa. If I try to use one of the parameter values up here in main, if I try to say like system.out.println, print the key, it'll tell me the key is not defined. That particular value doesn't have any scope up here in my main program. It's only defined down here in my method. So remember that scope is an important part of writing programs that involve methods. Scope for particular variables always starts at a particular line where it's defined in the program and continues through the closing curly brackets. If we need to pass that information to code that's in a different section of our program in a different method, then we have to pass that using arguments, which are in the method call, and parameters, which are the placeholder names that we use as we write our algorithm.